going to do a few problems where we're just using our potential charts. And again, so let's see what it's asking. Well, we should notice that it's asking for the weakest to strongest anode. And so when we know anode, we know we're talking about the oxidation reaction. In other words, we're going to be comparing their oxidation potentials. Well, I should recognize that these are not oxidation reactions as written. These are reduction as written. And of course, I don't even have to see that to know, because they're gaining electrons. And so these are not oxidation potentials. We're going to have to mess with those a little bit. These are reduction potentials. Okay, so let's look at our reactions and kind of see what we're wanting. Let's just start with silver. If it's being oxidized, that means it's giving up electrons. And if it's giving up an electron, I'm going to have it giving up one, just because I know that silver forms a +1 ion. But if you didn't, you would just look over here and find silver right there and see that its reduction potential is 0.8, but its oxidation potential, we have to change the sign because we want the opposite reaction. You see how this reaction is the opposite of the one I have here. So I'll change the sign. Okay, and so just to know, they're the same number and opposite sign. So let's look at what the other reactions would be. The next one is the iodide ion, and that's different because it has a negative charge. So I'm going to look for it over there and see where I can find it, but I bet this will go to a neutral iodine, and I'll need 2 of this. But if I wasn't sure, I would look and see, and I find it right here. And so again, for its oxidation potential, I'm going to take that number and change the sign. Okay, and last one. And on this one, so I'm going to have it giving up electrons, which is unusual because it's already given up 2. But if it's going to give them up, well, it could go to, how many is it going to give up? Well, I could look over here and see, but from 2, if it's going to give up more, it might go to 3. And if I look, I find it right here. It's the opposite reaction, but it's the difference of 1. So I'm going to go with that. And again, change the sign. Okay, so I found my oxidation potentials. And now to answer the question about which one is the best anode. Because anode, so best anode equals most positive oxidation reduction, or oxidation potential. Well, none of these are positive, so none of them are great anodes, but I want to go with the best one would be the one that's least negative. So the best one is the iodine. So I'm going to write it over here because it's the best. This is the strongest anode. And then the middle one, of course, will be the 0.77. So it'll be the iron. And then, of course, I'll have the silver. wasn't that one.